Yes, I feel very tall for being able to reach that. All right, so I want to do 8.5 number 22, which says, tell us all the everything about this graph. So here we have a graph, and I think the first thing, part A, was vertex.
Or direction.
I think it's vertex.
Okay.
It's vertex. So where's the vertex? I've only done about 4.
1, -4.
That's this guy?
Mm.
Cool. So that's at 1, -4. Okay. Does it open up or down? Whoa. Up, I think. Okay. Let's see. Then C is x-intercepts.
5, 0, -3, 0.
Okay. So 5, 0, and -3, 0. Right? Stating the y's on the x-intercepts is a little bit redundant, right? Good to
Did
go?
we just say 5 and -3?
Yeah, because I know the y's are 0, right? Otherwise, they wouldn't be the x-intercepts. How about the y-intercept? That's part
-3.
B. Y-intercept is -3. And again, we could phrase that as a point if we wanted to, but I think -3 probably suffices. Please note there can be lots of these, right? Tons of x-intercepts. Why can there only be one y-intercept?
Because there's only one function.
Close. The right word was function, I think.
Because you only have the line test, so it wouldn't pass the line test.
Yeah, it would fail the vertical line test if it hit twice, and then it wouldn't be a function, and then we wouldn't be talking about A through J, right? All right, so how about E, which is domain?
All real.
All real numbers,
How'd you figure that out?
because it's
Squash it to the x-axis.
it's on X. Everything squashes on.
Yeah, squash to the x-axis. Cool.
Yeah.
All right. How about the range?
-4 to infinity.
Yeah.
So that's squash onto the y-axis.
Yeah.
So I'm down with -4 to infinity. And what brackets do you put on this thing?
Close bracket on -4 and open on.
Okay, open on the infinity for sure, right? And then I have to ask,
Include.
is there an input that gives you the output -4?
Yeah.
It's included.
Yeah,
Include.
it's 1 specifically, right?
There we go.
Remember, this guy's an input-output pair, right? Okay, then what else do we want? We want
Positive.
positive, negative. So what are the x values for which this thing's positive?
-infinity to -3. Union.
Okay. -infinity to -3 and
5 to infinity.
5 to infinity. What brackets do you put on this? It depends. Do you count 0 as positive or not? So if we said bigger than or equal to 0, then what would I put for brackets on this? When you put -3 in, does it?
It's the closed.
Yeah, when I put -3 in, I get 0 out, right? So that's okay in terms of bigger than or equal to 0. Why did I pick those two? So kind of this stuff down here is negative, right? This stuff up there is positive. So I'm wondering, when did my picture cross from being up here to being down there? Well, it crossed here at -3 in the x's.
Yeah.
And it crossed again at 5 in the x's. Okay, h is negative. So let's phrase that as strictly smaller than 0.
-3.
Wait. I want Audrey, go for it.
This stuff below the
Yeah,
x-axis.
it's the option we just did.
Brackets or opens?
Oh, no, no, no.
Because I said strictly,
Yeah.
they're opens.
They're open.
It's
Because there's no, it's not
less
less
or equal to.
or equal to. The equal to means it's a bracket.
Does that make sense, Logan?
Yeah.
Do you realize that I think we're probably going to be able to hear you on a video? Told you I'd get you on one of them. I know. And we lost all the volume again.
How many lines are in this?
All right, so how about part I? What's I? It's asking for when is it decreasing? So what does decreasing mean?
From -3 to -4.
No, from negative infinity to 1.
Remember that one's about if I was on this graph walking along,
Oh, that's
Yeah.
right.
right, from left to right, when would I be going downhill is decreasing, right? So,
From negative
Oh,
infinity.
Negative infinity, yeah.
right, I'm walking downhill the whole way from all the way over here till I get to 1 when I hit the bottom. So minus infinity to 1. And this one's open for sure, right? Because minus infinity doesn't make any sense to put in there.
Mine's
And-
open too, because you don't know where the flat spot is.
Yeah, one's open because if I'm standing at the bottom, right, I'm not walking up or down. I'm kind of,
At a
Stuck.
90-degree angle.
right? Put your foot in there, you'll get stuck there for good.
Yeah. That's the fun part.
All right, how about J? J is the other thing, right? Increasing. Okay, so when's it increasing? What's increasing mean in terms of the little guy on the graph?
Walking uphill.
Walking uphill, so when's he walking uphill?
From 1 to infinity.
To infinity.
1, same place. But you
Remember, there's a nice, easy way to, or there's an easy thing you can check here at the end. These two things together should be pretty much all the everything, right? Because he's going to be either walking up or walking down. Maybe if there was a big flat spot, we'd be in trouble, right? But they should add up to basically all the everything. What's that about? Why 1 and not -4? Because I'm counting this in the x. So think about this as times. And think about me walking along in time, right? So when am I walking uphill? Well, the times are here. So from 1 onwards.
Okay.
So you'd be like,
How would have I phrased another way? The book actually asks the x values for which this is increasing. Where do the x's live? They live on a horizontal axis, right?
Yeah.
So I'm asking, when I'm walking along uphill, right? At what x does that start,
Starts at 1.
right? This is a point, right? This point here.
Is that
It's
1,
1 comma whatever, and I don't care that the whatever is -4 because I'm only interested in the x value for that thing.
So,
Does that make sense?
Yeah.
Because remember, we really phrase increasing, decreasing, and positive, negative in terms of x values, right? There's a lot of stuff.
I know, it doesn't stay in my brain.
So you
Yeah.
could
It
you just
takes-
remember that the decrease and the increasing is going to start at the x on the vertex?
Yeah.
Yeah.
Yeah, so another thing you could know is that, right, the vertex is the spot where it switches from going up to going down.
Yeah.
And so I go from the beginning till the vertex for one of them and from the vertex to the end for the other.
Yeah.
That works as long as there's only one vertex, right?
Yeah.
Yes.
If I drew another picture that looked, something like this,
Yeah.
then I've got a little bit more thinking to do, right? Because there's an uphill bit, a downhill bit, and an uphill bit afterward. Cool? Question?
Is there going to be one of these on
Yes.
top?
I
What?
hope so.
You don't want to do this one?
No.
That's okay. That,
I hope there's one.
I already Xeroxed it though.
Is there a question like this on the test?
Yes.
There's part of one of these on the test, it's not the
That's all
whole
I
one
asked.
thing.
That's all I want to know.
It's